Good everyone. So in this session we're going to do trigonometry and we're going to cover trig identities. So I have the questions here. The exam questions, one was asked from 2016-2017 exam and the other one is from 2023-2024 last year's exam. So these were the questions which are asked and we'll do them at the end of the coverage of the topic. So before we can delve any further, let's first try to understand the trig identities which we are going to use in order for us to be able to solve these trig identities. Okay, let me go to the next slide. Alright, so we're doing trigonometry identities. Okay, so under trigonometry identities, we need first to understand the basic trigonometric identities, just the basic ones, the cos, the sine, and the tan. Then after that, we'll be able to understand the inverse of those basic identities. Then we'll be able to understand the double angles for those trig identities. Then we'll look at the half angles and we'll be done with the coverage for this part, trigonometric identities. So let's begin with the basic trig identities. Okay, all right, so the best trig identities we have the sine, okay, so we have the sine theta. The sine theta, we know that it is given by the opposite over the hypotenuse. Then we also have the cos theta given by the adjacent over the hypotenuse. We also have the tan theta given by the opposite over adjacent. We can use a mnemonic to memorize this, the common one which is known as SOHCAHTOA. Okay, so this is a mnemonic you can use, or just a memory aid, in order for you to remember what sine theta is. It is just opposite over hypotenuse. The cos is adjacent over hypotenuse. The tan is simply the opposite over adjacent, basically that. Okay, so if you have this, if you can understand this, then you're all to go. The second thing you need to understand are now what are the inverses. Okay, so we have the inverse for sine theta, the inverse for sine. So we are saying inverse is simply 1 over sine theta. Now what is the trig identity which denotes 1 over sine theta? So for 1 over sine theta, it is cosec theta. For you to be able to know the trig identity they are referring to, just count the 3 letters COS. So you look at S, so that is the inverse for sine. Cosec, it is simply 1 over sine theta. Then let's also understand sec. So we are saying we just count the third letter. So cosec will be simply the third letter, that is C, and C is coming from cos, so cosec is simply 1 over cos theta. Then the other thing we need to understand is the cotangent, okay, commonly written as cot. What is cot theta? So cot theta is simply, we look at the third letter, which is T, so it will be 1 over tan theta. But this cot theta, we know that tan theta is simply equal to sin theta over cos theta. So we can derive another identity for cot theta. We can basically say cot theta is equal to 1 over sin theta, tan theta. Tan theta, we said it is simply sin theta over cos theta. So you simply interchange this, you'll be able to get cos theta over sin theta. So that is the basic trig identity for cot theta. Now let's look at the branch, or the root rather, from which all these identities come from. Okay, let's look at the root of all these trig identities. So I'll draw a triangle. I'll draw a right angle triangle here. So let's say this is my 90 degrees. We have y, we have r there, and we have x. We can use Pythagoras theorem, which says the square of the hypotenuse is simply the sum of the square of the adjacent and also the opposite, which is r squared is equal to x squared plus y squared. Okay, so we can use this in order to derive the root of all these trig identities. So we can say, let me clear this part. So since we have this, okay, since we have this, we can derive something here. Okay, so we know that sin theta, we are considering theta to be at that point. We know that sin theta is simply the opposite. The opposite is just the side which is in opposite direction to the angle under consideration. So the opposite is y over the hypotenuse, that is r. Okay, then we can also look at cos theta. Cos theta is simply the adjacent, it will be x over the hypotenuse, which is r. So you can substitute these two trig identities in that Pythagoras theorem for us to derive the root of all these trig identities we talk about. Okay, so we can say now that r squared will be equal to, so r squared will be equal to, we have x squared plus y squared. So what we're going to do here, we're going to divide on both sides. Okay, we're going to divide throughout by r squared, even there by r squared. So r squared over r squared is just 1. So 1 will be equal to, here we can just use the law of indices and we'll be able to get x over r. Then you just get rid of the square, so you write the square outside, then plus this also will be equal to y over r, then the square outside. So we can see that we have found x over r. X over r is simply cos theta. Then we've also found y over r. So y over r is simply sin theta. So we can do the substitution there. So we can say 1 is equal to cos, remember this was squared, so cos theta squared plus sin theta squared. Okay, so we're going to have 1 is equal to cos theta squared is simply cos squared theta plus sin theta in brackets square, that is simply sin theta squared. So this is the motherboard of all these identities. This is where all these identities are derived from. So from this simple identity, which is sin squared theta plus cos squared theta is equal to 1, right? So if we know that, we can derive other identities. So we have sin squared theta plus cos squared theta is equal to 1. Now what if we divide everything by sin squared theta, even there by sin squared theta, even there by sin squared theta? So we're going to have sin squared theta divided by sin squared theta, that is just 1, plus cos squared theta over sin squared theta. We said this is simply cot squared theta. Okay, cos over sin we said is cot, then 1 over sin theta we said it is cosec, so this will be cos squared cosec squared theta. So we've derived another identity, which is 1 plus cot squared theta is simply cosec squared theta. Let's look at another identity. We'll be using the same identity, sin squared theta plus cos squared theta is equal to 1. At this point around, let's divide everything by cos squared theta, even there by cos squared theta, and there cos squared theta. So sin squared theta over cos squared theta, that is simply tan squared theta, then plus cos squared theta over cos squared theta, that is just 1, is equal to 1 over cos squared theta, that is just cot, mean 1 over cos squared theta, we have 1 over cos squared theta, so that is sec, okay, that is sec squared theta. So we can derive, or we can now say that tan squared theta plus 1 is equal to sec squared theta. That is very important for us to understand. Now let's look at what are known as double angles. Let's look at this, something interesting called double angles. So for double angles, you just need to know, what if an angle is added? Let's say cos A plus B. What could be the result? Okay, cos A plus B. What can you get if we add these two angles? No wonder they are called double angles. So when you add cos A plus B, cos A plus B will be equal to cos A cos B. To remember this, you need to know that cos is selfish. So cos A plus B will simply cos A, again cos B. Then you interchange the sign. There is plus there, it will be minus. Then you say sin A, then sin B. Okay? So what if there was minus here? Okay? If there was minus here, you simply interchange the sign there. That would have been a plus there. Alright, so if you understand this, let's now look at what about if we have cos, let's say cos A plus A. They are same angles. Okay, cos A plus A is simply cos 2A. Now which identity is used to refer to this? So excuse me, so cos A plus A, you simply say cos A cos B, I mean cos A again, since the angles are similar. Then you interchange the sign, that will be minus sin A sin A. We know that cos A, that is cos squared A. When you're multiplying cos A multiplied by cos A, that is simply cos squared A sin A times sin A, that is simply sin squared a. So we are now safe to say cos a plus a, which is simply cos 2a, is equal to cos squared a minus sin squared a. Let's do for sine a plus b, the double angle for sine. So this is simply sine a cos b, sine is not selfish, plus cos a sine b. Okay, if there was minus there, it would have been minus even there. Okay, now let's have a situation whereby you have the similar angles. Let's say sine a plus a. Sine a plus a is equivalent to sine 2a. Now let's find what is sine 2a. So we use the double angle for sine, so it will be sine a, then cos, that is cos a, plus cos a sine a. And these are similar, they are like terms, so they can add sine a cos a plus cos a sine a. That is simply just 2 sine a cos a, basically that. So that's how you can derive that identity. Now what if you have tan a plus b? What is the identity for tan a plus b? So you need to understand that tan a plus b is equivalent to tan a plus tan b, then over 1 minus tan a tan what b. So for tan, if you have a minus there maintain a minus, then on the denominator you need to swap, it should be a positive or a plus. Okay, now what if you have similar angles? Let's say you have tan a plus tan a. We know that tan a plus tan a, that is simply tan 2a. Now what is the identity? So we're going to say tan a plus tan a, these angles are similar, over 1 minus tan a tan what a. So let me rub the top part here. So what we have is that tan a plus tan a is simply 2 tan a. Then what is 1 minus tan a tan a? You are multiplying tan a by tan a, that is tan squared a. So what you are going to have is this. So you are simply going to have over 1 minus tan squared a. So this is equivalent to tan 2a. So this is the double angle for similar angles of tan a. As simple as that. Now let's look at half angles. We've exhausted the double angles. Now let's look at half angles. Okay, let's understand half angles. So half angles are coming from the background of double angles. For double angles, we said let's start with sine. Okay, let's start with cos, the same one. So we said that cos 2a, we had cos squared a, if you remember, minus sine squared a. And from this we can derive another identity for cos 2a. So for cos 2a, we can even say that this is equivalent to cos squared a, then minus, we know the identity for sine squared a. Sine squared a is simply 1 minus cos squared a, because we know that cos squared a plus sine squared a is simply 1. So to get sine squared a, we simply interchange. The cos goes to the other side and turns to negative. So we're going to have cos squared a, cos 2a is equivalent to, this is simply negative multiplied by negative, it will give a positive. So we're going to have cos squared a plus cos squared a, we're going to get 2 cos squared a, then minus negative times positive 1, that is negative 1. So the identity for cos 2a is also given by 2 cos squared a minus 1. Now let's derive the half angle for this one. So we are saying cos 2a is simply 2 cos squared a minus 1. Now for half angles, it means that the angle, you divide it by 2. Even there, you divide the angle by 2. So 2 into 2, it is just 1. So we're going to remain with cos a. Cos a will be equal to 2 cos squared a over 2 minus 1. What do we want to get? We want to get the half angle for cos. Okay, let me wrap the top part there. So we can now collect the like terms. So we have 2. What we want is the half angle to be on the left hand side. So it will be 2 cos a over 2, and this is squared, mind you. It will be equal to this one will go to the other side. So it will simply be cos a plus 1. Okay, let me get rid of the bottom part. So what we can do here, we can divide by 2 here. Even there, by 2, we divide on both sides by 2. To get rid of the square, we can just find the square root on both sides. So that square will cancel with the square root. So we're going to remain with cos a over 2 is simply equal to, and we know that the result from the square root can either be positive or negative. So it will be cos a plus 1 everything over 2. So that is the half angle for cos a over 2. The half angle for cos, it is simply positive or negative square root of cos a plus 1 over 2. Everything must be in the square root. Let's look at the half angle for sine. Okay, for sine, we are coming from a background where we've discussed that cos 2a is simply given by this identity, which is cos squared a minus sine squared a. Okay, let's do some manipulation here. Okay, let's do some manipulation. So we are going to take now this cos squared a out of this equation. How can you take this out of the equation? We can just substitute 1 minus sine squared a. So you can say cos 2a will be equal to, where there is cos squared a, we substitute 1 minus sine squared a. Then across brackets, then minus sine squared a. Now at this point, we can do what is known as addition. We can do our algebra. So it will be cos 2a is equal to 1 minus sine squared a, negative sine squared a minus sine squared a, that is simply negative 2 sine squared a. Now let's now derive the half angle for sine. So how are we going to derive it? So here is the thing. So what we are going to do is that we're going to take this sine squared a into to the other side. Okay, we're going to take it to the other side. So we're going to say 2 sine squared a will be equal to, here we are going to have cos 2a. This will become negative 1 this side because it was positive. Okay, let me get rid of this. Then what we can do here, we can divide now the angle by 2. Even there, the angle by 2. So 2 will cancel with this 2. Don't cancel the angle with the coefficient of the trig function. That is not mathematically right. Okay, so what we can do here is just to divide now. Okay, so we have sine a over 2 is equal to cos a minus 1. To get rid of this, which is to get rid of this coefficient, which is 2, we can divide by 2 on both sides. To get rid of the square, we can find the square root on both sides. Okay, so basically we have positive or negative there. So let me get rid of this. So what we have now is that sine a over 2 is now equal to, because that square will cancel with the square root, is now equal to square root, and the result is can either be positive or negative. Now square root of cos a over 2, not over 2, sorry. Okay, let me rub this. So it is cos minus 1. So let me just rub what is inside here. So it is cos a minus 1, then everything is over 2. Okay, so that is simply the half angle for sine. The half angle for sine. Now, what is the half angle for tan? So this is very interesting. When you have sine a over 2 is equivalent to, okay, let's now forget about the positive or negative thing. We know that what comes out of the square root can either be positive or negative. So when we have this to be equal to square root of 1 minus cos a over 2, and we know that for cos, the half angle for cos over half angle for cos is simply equal to 1 plus cos a over 2. You can simply find now the half angle for tan, because we are coming from a background where we've discussed that tan theta is simply sine theta over cos theta. So even sine 1 a over 2, that is the angle for tan. So even tan a over 2, okay, even tan a over 2, let me just get rid of this. Okay, so even tan a over 2 is simply equal to, so sine, what was, so we have sine a over 2 over cos a over 2. Now what was the angle for the half angle for sine? The half angle for sine was square root of 1 minus cos a over 2. Okay, the half angle for cos was square root of 1 plus cos a over 2. Now let's find the half angle for sine now. I'll get rid of this. I no longer need it. So it will be tan a over 2 will be equal to, so here you can do some algebra. So you can simply say square root of 1 minus cos a over 2. Here we are dividing, okay, and this square root must just end at this point. Okay, okay, so we have that like that. Okay, it should be like that, yes. So this is simply equal to, so I'll wrap this. So we are dividing, so divide by square root of 1 plus cos a over 2. Now let's find what is tan a over 2. So this will be equal to, when you have this, according to mathematics, this is simply 1 over cos a over square root of 2. Then here divide by, same applies to this one, you can just distribute the square root, so it will be equal to 1 plus cos a, even there, over square root of 2. So if you interchange this, if you find the reciprocal, you will discover that when you change this sign into multiplication, when you change the sign to multiplication, let me just wrap this apart. So when you change into multiplication here, this denominator will be the numerator and the numerator will come down as the denominator. Okay, so what I'm simply saying is this: when you interchange, you simply have root of 2 on top, then at the bottom you have 1 minus cos 2a. So at this point now you can cancel square root of 2 and square root of 2, and you remain with tan a over 2 to be equal to square root of 1 minus cos a. That should only be a. Okay, so this is what you are going to have. Let me just erase this part. So what you are going to have is tan a over 2 will be equal to square root of 1 minus cos a over, let me wrap this part, over square root of 1 plus cos a. So basically that is the identity for half angle of tan. Okay, as simple as that. Now let's now solve the questions. We've exhausted all the identities which you need to know. Okay, let's solve the questions in the next few minutes. So I'll go back to these questions. The first question came from 2016-2017 exam. It was prove the identity 3 sin x minus sin 3x is equal to 2 tan x minus that is multiplied by sin 2x divided by cos sec x. So we are proving the identity. Okay, so let's do this. So the question we have, let me just review it once more. Okay, it is 3 sin x minus sin 3x is equal to 2 tan x sin 2x over cos sec x. So we know that when proving, you need to take one side, and after you prove it, it should give you the result of the other side, and usually we take the complicated side. But for this instance, it is very difficult for you to get this value and get back to this. It is very difficult. It will be a struggle. So what do you need to do? You need to prove on both sides. Okay, so you need to say left hand side. Left hand side is simply 3 sin x minus sin 3x. Okay, let me give you an identity for sin 3x. So there's a certain identity we use for sin 3x. So for sin 3x, the simplified identity, you just say 3 sin x, okay, sin x, then minus 4 sin cubed x. So this is what we are going to substitute here. Okay, so let's substitute that. Okay, so it will be, it was 3 sin x, okay, 3 sin x, then where there was sin x, here there was sin 3x, I mean. So where there's sin 3x, we'll substitute simply that. So let's substitute. So it was minus 3 sin minus sin 3x. So we'll substitute this on that. Okay, So let's do the substitution. So it will be minus 3 sine x minus, and this must be in brackets, okay, minus 4 sine cubed x. We've substituted the identities for sine 3x. Sine 3x is just 3 sine x minus 4 sine cubed x. So what are we going to have here? We're going to have 3 sine x. If you multiply this negative by positive 3 sine x, you're going to get negative 3 sine x. Then negative by negative, that is simply positive. So there we're going to get 4 sine cubed x. So 3 sine x and 3 sine x can cancel, okay, can subtract, and that is simply 0. So what do we have on the left hand side? On the left hand side we now have 4 sine what? Cubed x. So this is what we have on the left hand side. So let me just write it there to reserve it. So we have 3 sine 3x, 4 sine 3x, okay. So now let's do the right hand side, okay. So we are now doing the right hand side. So the right hand side was 2 tan x sine 2x, then everything was over cosec what? X. So you can do something here. We know that let me just get rid of the top and write it a bit on the top. So it is 2 tan x sine 2x over cosec x. Okay, I'll get rid of this. Alright, so how can you manipulate this? So we know that tan is simply sine x over cos x. Then this is multiplying with sine 2x. From our identities, we've learned that it is 2 sine x cos x. Then we even know that cosec x is simply 1 over sine x, okay. So this cos will cancel with that cos. So we're going to have 2 sine x multiplied by 2 sine x, and that will give 4 sine squared x over 1 over sine squared 1 over sine x, okay. So we are going to have 4 sine squared x. Then this 1 over sine x can also be written as multiplied by, so this is one expression. Let me just use a dot there. We are multiplying by 1 over sine x, which can also be written as sine x over 1, and this is simply just sine x. Then what are we going to have? What we are going to have is 4 sine square x multiplied by sine x. That will give us sine cubed x. And this is our right hand side. You can see that the right hand side is equal to the left hand side, which we had, which was 4 sine 3x. And that is how you can prove this identity. So you can just say hence proved, okay. We can now say hence proved. Now let's look at the second question. Now was the second question. The second question, which was asked in 2023-2024 exam, was cos theta divided by 1 minus tan theta plus sin theta over 1 minus cos theta is equal to sin theta plus cos theta. Okay, let's do this. Okay, so the question we have, we are proving that cos theta over 1 minus tan theta then plus sine theta over 1 minus that is simply cot theta, okay, is equal to sine theta then plus cos theta. So we are taking the left hand side, which seems to be a bit complicated. Taking the left hand side, okay. So if we take the left hand side, what are we going to have? So we know that this cos theta over 1 minus tan theta, that is simply 1 minus sine theta over cos theta, okay, then plus sine theta. This 1 over cot theta can also be written as 1 minus, we learned the identity for cot is simply cos theta over sine theta. Then you can simply now do multiplication there. Okay, let me get rid of this. So we can now say cos theta over, you can do the subtraction there. The simplest way to do subtraction in an exam, you just multiply this by this. So cos theta multiplied by 1 minus cos theta, you find that the answer is 1. The answer is cos theta, sorry. Cos theta, then minus sine theta. Then you maintain the same denominator. You maintain the same denominator. The denominator was cos theta, yes. Then you go to the other side. Okay, to the other side, you're going to say, you do the same. So this is plus, and this is our denominator. So plus sine theta over, you do the same. You just do the simplest way of subtraction. So it will be 1 times sine theta, that is sine theta minus cos theta. Then you maintain the same what? You maintain the same denominator. So over the denominator there, what was the denominator again? It was sine theta. Now at this point we can interchange this, okay, because this is simply division there. So it will be equal to, let me just get rid of this. So we're going to multiply cos theta by cos theta on top, because this is division, so we find the reciprocal. And even on this side we do the same. So what are we going to have? So let me just wrap this part. Don't want to wrap the right hand side, because this is giving us an overview for what we should have. So what I'm saying is that we're going to have cos theta multiplied by cos theta over the denominator, it is cos theta minus sine theta. Then this was adding plus sine theta, so you multiply by sine theta over, here it was sine theta minus cos theta, if you recall how it was. So cos squared theta, cos theta multiplied by cos theta, that is simply cos squared theta over, here we are going to have cos theta minus sine theta, then plus sine squared sine theta multiplied by sine theta, that is sine squared theta, okay, over sine theta minus cos theta. Now let me get rid of the top part. Okay, where are we going? We are going to sine theta plus cos theta. Okay, so what we can do here is this. We can now do some algebra here by just interchanging this. Okay, we can factor out negative to be on this side, then there it will be negative sine theta, then there it will be positive. We haven't changed anything, we have just done the factorization. So it will be cos squared theta over cos theta minus sin theta, then negative there multiply, divide by positive, that will give us a negative. So it will be sin squared theta now. To my writing, so sin squared theta over this one we can interchange. We'll start with what has a positive, so it will be cos theta minus sin what theta. Okay, let me get rid of this. Right, now what can we do at this point? At this point, what we can do is that we can now subtract. The bases are the denominators are the same. So we are going to say cos squared theta minus sin squared theta over just one denominator, because the common denominator is just cos theta minus sin theta. At this point now, you can do difference of two squares. Okay, apply the difference of two squares, because that is what is being applied there. Let me grab this part. So according to difference of two squares, you just start with the minus, so cos theta minus sin theta, then you put in bracket, you multiply by the opposite. Now you take cos theta, here you add, okay, you add sin theta, you put a positive sign, then over the denominator we have is cos theta minus sin theta. Let me rub this. We can see now that sin theta over sin theta, this can cancel, okay, and we are remaining with cos theta plus sin theta, which was there. Okay, so this is the right hand side, and we can see that it is giving the same value. So this is how you can basically solve. Thank you for watching. Have a great day.